We've all been there. It is the dead of winter, the wind is howling, and no matter how many layers you wear, the cold just sinks right into your bones. You reach into your pocket, pull out a little plastic packet, and give it a good squeeze and a shake. Almost instantly, a wave of warmth floods into your freezing hands, giving you exactly what you need to make it home. That sudden burst of heat feels like magic, but it is actually just chemistry at work. Inside that little packet were two completely isolated substances that, until you broke the seal, had never touched. When you shook them up, you kicked off what scientists call a combination reaction. That simply means two separate things merge together to create one brand new thing. The incredible warmth you feel on your skin is the physical release of trapped energy. It is the natural result of those chemicals successfully joining forces. This image is the cover of a standard science textbook, and the invisible process that heats up your hands is the exact same one featured in its opening chapter. We can see this reaction up close in a lab. We start with a beaker filled with a dry white powder. The scientific name for it is calcium oxide, but you will often hear it called quicklime. Next, we take ordinary liquid water and pour it directly onto that dry mound of chalky white powder. The moment those two ingredients touch, the mixture begins hissing, popping, and bubbling violently. Looking at this thermal camera view of the beaker, you can see it glowing a brilliant, dangerous red and orange. If you tried to touch that glass right now, it would burn you. Inside that glass, the water and the quicklime no longer exist as separate items. They have permanently fused together into a single new substance known as calcium hydroxide, or slaked lime. That bubbling beaker operates on the exact same principle as your winter hand warmer. Two distinct ingredients fuse together, violently ejecting their leftover energy as heat in the process. When scientists write down what just happened in that beaker, they use a chemical equation. You can think of this as a simple baking recipe. Our ingredients are on the left: CaO, our quicklime, plus H2O, liquid water. When mixed, they yield a single product on the right, slaked lime. This combination also produces one massive byproduct. It generates heat. Whenever a chemical event releases heat like this, scientists call it an exothermic reaction. It's an easy word to remember if you break it down. Exo means outside, and therm means heat. The heat is pushed out. So anytime you see a chemical recipe that ends with plus heat, you know you are looking at an exothermic combination. The molecules lock together so tightly that they squeeze their excess energy right out into the real world. You might wonder why people bother mixing up slaked lime in the first place. For centuries, humans have used it as a tough, protective coating for their homes. If you have a dull, plain wall, you can take that wet slaked lime mixture and paint it directly onto the surface. This is a traditional process known as whitewashing. This cross-section shows the slow, invisible reaction that happens over the next few days. The wet slaked lime on the wall reacts with the carbon dioxide gently drifting in from the air, physically locking those particles right into its outer layer. As that reaction finishes, the damp paste solidifies into a bright, shiny, impenetrable white shield. That hardened layer is now calcium carbonate. It is the exact same incredibly strong material that nature uses to build ocean seashells. Whether you are warming up your freezing hands on a winter walk or looking at the brilliant white walls of a painted building, you are witnessing the same principles at work. Combination reactions are simply the universe's way of joining distinct forces together to build new things, leaving a physical trail of heat and transformation behind.